Today in Algebra 1b, we begin our work in Unit 8, Day 1, defining polynomials. To begin with, let's talk about what a monomial is. A monomial is a number, variable, or the product of a number and one or more variables with non-negative exponents, integer exponents. Helpful hints: a monomial is only one term. If there is an addition or subtraction, it's not a monomial. If there's a variable in the denominator, it's also not a monomial. For example, these are monomials: 5x, 3y squared, 8x cubed y to the 7th, 10 are all monomials. A number, or the product of a number and a variable, or one or more variables. These are not monomials. 15x to the negative third, because the exponent is a negative integer. 25x minus 3, because there's a subtraction sign. 16 divided by x to the fourth, because there's a variable in the denominator. Those are not monomials. The degree of a monomial. The degree of a monomial in one variable is its highest exponent. If a monomial has multiple variables, then the degree is the sum of the exponents. Even if the variables are different letters, it's still the sum of the exponents. For example, find the degree of each monomial. (14x to the 8th, 32x squared y to the 5th, negative 12, 18wt cubed, and 5x. Those are our 5 monomials. Let's find the degree. 14x to the 8th only has one variable, therefore it's the exponent of that variable, 8. 32x squared y to the 5th has multiple variables, therefore the degree is the sum of those two variables, 7 in this case. Notice that in number 3, negative 12 has no variable at all, therefore it's a degree of 0. 18wt cubed, remember, even though there's not a power on w, it's the ninja 1 plus 3, degree of 4. Same thing in number 5, the 5x, ninja 1 power, its degree is 1. Polynomials. A polynomial is a collection of monomials joined by addition or subtraction. Since each term of a polynomial is a monomial, each term has a degree. The degree of a polynomial is the highest degree of any of its monomial terms. Example: find the degree of each polynomial. 14x cubed plus 20x squared minus 90. 2x squared y cubed plus 9x to the 4th y squared minus 21xy to the 6th. And 8x to the 4th minus 12x cubed plus 5x squared minus 20x plus 11. Our first example, the highest degree, the degree of the first term is 3, second term is 2, third term is 0, so the degree of the polynomial is the highest of those 3, 3. In number 2, the degree of our first term would be the sum of 2 and 3 or 5. Here it would be 6, and the final one would be 7, because we'd add the 1 and the 6. So therefore, the degree overall is 7. In our last one, the degree of the first term is 4, second term is 3, then 2, then 1, then 0. So the overall highest power is 4. So we continue our work with polynomials. We classify polynomials, and we do it in two different ways. We first classify polynomials by the degree. A polynomial of 0 degree is a constant. You'll also notice a constant never changes, which means it has no variable. polynomial of degree 1 is linear. Degree 2 is quadratic. 3, cubic. 4, quartic. Let's look at some examples. Classify by number of terms. These are things you just have to memorize and know. If it has one term, as we've seen, it's a monomial. No pluses or minuses. 2 terms is a binomial. 3 terms, trinomial, just like a tricycle or a tripod. And any polynomial of 4 or more terms is just simply a polynomial. It has no special name. The standard form of a polynomial. A polynomial is written in standard form when its terms are written in descending order by their degree. For example, write each polynomial in standard form. 7a plus 4 minus a squared. And our second polynomial, x cubed minus 9 plus 2x plus 8 minus 4x. In our first example, the polynomial with the highest degree is actually the third term. The third term is the one with the highest degree because it's a degree of 2. So it's going to come first. Then the 7a, which is degree 1, and then finally the constant of 4. Notice that the signs that were in front of the respective terms stayed there. So a squared, even though it was last, is still negative when it comes first. The 7a is still positive, and the 4 is still positive. Now, in example 2, we actually have to do a little simplifying as we go. The first term was the one with the highest degree, x cubed. 2x and 4x are both degree of 1, so we're going to combine those together by combining their coefficients. So 2 minus 4 gives us negative 2. And finally, the constants of negative 9 and 8 are also like, so we combine those in our standard form, x cubed minus 2x minus 1. Finally, today, we talk about adding and subtracting polynomials. We add or subtract polynomials by combining their like terms. Remember that like terms are terms that have the same variable raised to the same power. Take a look at our examples. Simplify will be the directions. Write your answer in standard form. T to the fourth minus 4t squared plus 9 plus negative t cubed plus 3t. And our second example is a subtraction. Let's do example 1. Notice in example 1, we actually have no like terms. T to the fourth, there's no other fourth powers, there's no other third powers, nor seconds, nor firsts, nor constants. So we just have to rearrange this to put it in proper form. Remember, in standard form, the highest degree goes first. So t to the fourth is first, then the t cubed, then your t squared, then your plus 3t plus 9. Again, standard form goes highest exponent to lowest exponent. Here in example 2, we have to subtract, and we do have like terms in example 2. The first terms, k to the third and k to the third. Those are like. So it's negative 6 minus negative 5. So minus minus, of course, becomes positive, and it becomes negative k cubed. 3k squared is the only k squared there, so it's going to go next, and it's going to be minus because the minus has to distribute through. 3k and minus negative 8k, those are like because they're both k to the first. So we get the final answer of negative k cubed, negative 6 minus negative 5, minus 3k squared because the negative gets distributed through, and then 3 minus negative becomes plus 11k. And that concludes Lesson 8.1 on polynomials.